Hi, everybody. In this video and the next few videos, we're going to be talking about factoring polynomials. And there's different techniques and different types of polynomials we're going to factor. So I've broken them down into smaller videos of different styles instead of trying to do everything in one big video. So in this video, we're going to talk about factoring polynomials, but specifically, we're going to do an introduction to what factoring is, and then do the most basic kind of factoring, which is factoring out the greatest common factor, or GCF. So factoring a polynomial means to find an equivalent expression for that polynomial that is a product. And if you think about the word product, a product is a solution to a multiplication problem. So factoring really means to take that polynomial and set it up as factors being multiplied together. And factoring and multiplication are opposite operations. And I think it's easiest to see with an example. So for instance, going from this direction to here, so actually taking those two factors and multiplying them out, that gives you your polynomial, right? And this is the process of multiplication. And going backwards, so starting with a polynomial that looks like this, that's a series of monomials being added, and going backwards to the two factors or three factors, whatever you have, that would be called factoring. So those two processes really work together. They go hand in hand, and they undo each other. So as we're factoring, one of the ways that we can check that we have actually found the correct factors for that polynomial is that we're going to multiply it back out and make sure we're correct here. So just a little side note here, just to kind of remind you what factors are before we get into polynomials. So for instance, if I'm doing something like 2 times 3 equals 6, the 2 and the 3 are the factors, and the 6 is that product. Okay, so again, the factors are what gets multiplied together to give that answer. And they're the same thing here. They look different because they have x's in them. They're polynomials, but when you multiply these together, you do get that answer. So these would be your two factors in this case. And then this we could also think of as a product, that final multiplication result here. Okay, so let's do a definition. So the greatest common factor, also we usually abbreviate as GCF to save time, is an expression of the highest degree that divides each term of the polynomial. So basically, you look at the polynomial, you look at all the different terms there, and you try to find what is in common to all of it. So what factor is in common to all of it? So if I do, again, kind of like a basic example here, okay, so let's look at, let's do 6 and 8. Again, I'm not doing polynomials just yet, I'm just thinking about factors. So if you think about 6 and 8, we want to know what is the largest number that divides each of these values, or each of these, we'll say, terms in this case. So I think about 6 and 8, I think about what numbers divide 6 and 8, what are their factors? So for 6, our factors are 1, right? Because 1 divides into 6, 2, 3, and then 6. Whereas for 8, our factors are 1, 2, let's see, 3, 4 works, 5 does not work, 6, 7, and then 8 works, right? So these are all the numbers that divide into 6 and 8. And the one that is in common, that is the biggest, is 2. So our GCF here is equal to 2 for the numbers 6 and 8. And we're going to do that same process, but for polynomials. So it's going to be a little bit harder because we're going to bring in x's as well, or any other variable we want to, but it's that same idea. You're looking for what is the most factor in common to everything. So let's do an actual polynomial example. Do green. So here I have a polynomial. And remember, a polynomial is just really a string of terms. And what you're going to see for polynomials, though, is your exponents are going to be whole numbers. So they're not that they're super easy, but they're not too complicated yet. So you're looking for each of these terms and saying, okay, what's in common to everything? So what I like to do is just go piece by piece. So I'll look at my numbers first, and then I'll look at my variables. So if I look at 4 and 8, I say to myself, okay, what number divides into both 4 and 8? And obviously 2 works, but 4 also works. So I picked the biggest one. So for 4 and 8, 4 is going to work. And then I look at x cubed and x squared. I say, okay, they both have x's, right? So I know I have at least an x in common, but how many x's do I have in common? This one has 3 x's, this one has 2. So they both have at least 2. So they both have at least 2 x's in common. So our GCF here is 4x squared because these go into each of those monomials there, or each of those terms. So we're going to factor this by factoring out the GCF. So your first step is obviously to find the GCF. I like to write the GCF out. I think it's a little bit easier, but if you can do it in your head, that's okay. And then what you do when you factor by factoring out the GCF is you're going to write that GCF first, and then you're going to put whatever is left over in parentheses. So I'm going to go ahead and divide. So if I look at my original polynomial, well, I'm taking the 4 out, right? 4 divided by 4 is just 1. So you could put the 1 in if you want, but you don't have to. And then x cubed, x squared. So if I'm taking x squared out and I had x cubed to start, I still have 1 x left over. So I'm going to leave that x there. Bring down that plus. Now for the next group, 8 divided by 4 is 2. I had an x squared, but I took the full x squared out. So I have no more x's left. So my final answer here is just 4x squared. And then again, 1 times x is just x, so I can leave it like this. And here's my result. Now you can always check your work, and you can check by multiplying. I know we haven't done a ton of review with polynomials yet, but we have done review with combining like terms and distributive property, so it's really nothing different. You're just going to be more careful with your x's. So I'm going to take that factor polynomial, and what I'm going to do is distribute that outside term. So let's see, I have 4x squared times x. Well, there's a 1 here, so I have 3 x's altogether. And then for the next set, 4 times 2 is 8, and then I just have the x squared. So you can see how it matches the original. Now, for the check, you could do that mentally if you want as you get more comfortable, but it is always good to check, particularly if you're not sure about factoring. So factoring tends to be one of those subjects that you just have to practice over and over and over again. And the more you practice, the easier it's going to get. It really does require practice. It's one of those things that for most people doesn't just come very naturally. So you really want to practice it and take your time with it. And check your answers so that you know that you're correct before you move on. Oops, factor. And I'm going to do a couple examples just like this, just kind of basic factoring, starting with that GCF. So here I'm kicking it up a little bit. I have 3 terms now. This is called a trinomial when you have 3 terms. So a little side note here. Let's do it. A little note. So a polynomial in 2 terms is called a binomial, which we saw up in this last example. And if you have 3 terms, that's called a trinomial. They're also still polynomials, of course. It's just that we give them more special names. So as you're reading through the text, if you see those terms, it just means how many. It's a polynomial with a certain number of terms. So this one is a trinomial. Okay. And then this one up here was a binomial. Because it has 2 pieces, this one has 3. So I'm going to start with that GCF, and I'm just going to look at all of them. I start with the numbers first. I see a -2, a 10, and a 6. So I say what number divides into all of those, and the best one is 2. I guess you could take a -2 out if you wanted to, and that would switch the signs of these two. But usually, unless they're all negative or mostly negative, I usually just take out the positive. So that's my GCF. If I look at my variables, this has an x squared and this has an x, but this one does not. So I cannot take out an x here because they don't all have it. So my GCF is just 2. So for my factorization, remember that 2 goes on the outside, and then I'm going to write whatever is left over. So for the first group, I factor the 2 out, but I still have that negative. So -2 divided by 2 is actually -1, and I have an x squared still. For the next group, 5 divided by 2 is, 10 divided by 2 is 5. And again, you still have that x. And for the last group, 6 divided by 2 is 3. So this is fine, or again, you don't have to have that 1 there. And that would be okay too. I'm going to skip the check here, but this is something, again, you can always check by multiplying back through, making sure that you have that original example to start with. Okay. So another example, 10x to the 4th, y squared minus 25x squared y. We're going to factor again by factoring out the GCF. So I like to write that GCF first, and I'm going to look at my numbers. So I see a 10 and a -25, and I notice that both of those are divisible by 5, right? That's the kind of best I can do. So my number is going to be 5. And then I do see that they both have x's and y's, but I have to be a little bit careful. So this one has 4 x's, and this one has 2 x's because of the exponent. So they have both, at least 2 x's, and they both have y's. This one has 2 y's and this one has 5 y's. So again, they both have at least 2 in common. So my GCF is 5x squared y squared. So that's going to go on the outside. And then don't forget the leftover part goes inside the parentheses. So here, 10 divided by 5 is 2. And then think about your variables. Well, this one had 4 x's and I took 2 away. So I still have 2 left over. Here I had 2 y's and here I have 2 y's. So I have no y's left over. -25 divided by 5 is -5 or -5. Here I have x squared, but I took x squared out, so I have no x's left over. Here I have 5 y's and I took 2 y's out, so I have 3 y's left over. And again, that would be my final answer. So I can always check by multiplying back through. Remember, when we multiply with variables, we just add those exponents. So when you multiply back through here, when you have x squared times x squared, 2 plus 2 is 4. So you do get that original back. And when you distribute over here, y squared and y cubed, 2 plus 3 is 5. So you still get that same exponent. So I want to just do one more example here that is a little bit different, but same idea. And we're going to factor now, oops, sorry, this polynomial here by factoring out the GCF. Now this one looks really different. It's pretty unique looking, right? So you still kind of have this addition sign in the middle, but notice that we have things being multiplied that are groups now. But that group is in both parts, right? They both have that x minus 1 group. So this here is actually a factor. When it is in parentheses like this, it's a factor, it's all together, it's being multiplied. So these are factors. So each of my terms has the same factor in common. So our GCF here is that x minus 1. They don't have anything else in common. This one just has an x squared and this one has a 2. So you still want to check the other factors to see if there's anything else. But we're noticing that they each have the same group. This is a factor, so that's our GCF. So when we factor, this goes on the outside, and then we still have the leftover in the middle. So if I look at the first group, what's left over? X squared. And in the second group, what's left over? Just a plus 2. Okay, so we can take this a little bit further. I'll do one more so you can see one more of the style. So same question, we're going to factor this by factoring out the GCF. And again, this one's a little bit different, but you want to notice that they each have this same group of y plus 5. Now here, I don't have anything in front. You do have something, there's always a 1 there. So you may want to just put that in just to kind of keep that placeholder. And then if you look, 2y squared, y, and -1 don't really have anything in common there either. They don't all have y's, they don't all have 2's. So really the main thing is that they each have this group of a y plus 5. So that is my greatest common factor. Okay. You can technically have a greatest common factor of 1 because you can always divide everything by 1. But usually we don't write that unless the question specifically asks for it. So maybe I'll just make that little note here up to the side. So if you have something maybe like 2x squared plus 3, if there's nothing in common between them, then technically your GCF is still 1 because you can always divide by 1. But again, normally we don't really write that 1 in unless there's nothing else. So just a little side note here. So nothing really in common. So that's why I'm not writing those extra factors of 1 in here as well. And then we're just going to do the same process. So that GCF was on the outside. And then in the first group, I have a 2y squared left. I have a plus y in the next group. And then here, you do need something to hold that place. I know it's just a y plus 5, but you need something there. So I'm going to use that -1. So every time you have a term, you do need a placeholder. So we don't typically write 1's in, but if you have nothing else, then you need to put that 1. So same thing here or here. If there's nothing else to write, you need to put a 1 there to hold that place. But otherwise, we've seen other examples of it's like 1 times something, you don't need it. But here I do. So I have that third term being represented.